Wait, before your thumb moves, stop. Because what you are about to see is not just another space mystery. This is something that shouldn't look the way it does. This is Mars, a world we were told is empty, silent, lifeless, a frozen desert under a pale sky. And yet, some formations don't look random. Some rocks don't look broken by nature. They look shaped, placed, structured, angles too precise, lines too straight, blocks that almost resemble fragments of something built. And here's where it gets unsettling. We expect chaos on Mars. We expect erosion. We expect dust and time to destroy everything. But we don't expect order. So why does some of it look ordered? Is it just the human brain searching for patterns? Or are we staring at geological coincidences so rare they feel intentional? Because if this is natural, it's nature behaving in a very strange way. And if it's not, then the real mystery isn't what we're looking at. It's what happened here. Take a closer look. Not as a skeptic, not as a believer, but as someone willing to question. If mysteries like this fascinate you, subscribe to All About Mars Surface and share this with someone who loves space enigmas. Because Mars may be silent, but silence doesn't mean nothing ever happened. This is All About Mars Surface and this discovery. Because this isn't the first time Mars surprised us. For decades, missions sent by NASA have been scanning the Martian surface. Rovers moving slowly across the dust, cameras capturing millions of images, data streaming back to Earth. And most of the time, what we see is exactly what we expect. Rock, sand, craters, wind-shaped terrain. But every once in a while, an image appears that makes scientists pause. A formation that looks too structured, too aligned, too deliberate. Not proof of anything, but enough to raise eyebrows. The human brain is powerful. It searches for patterns everywhere. Faces in clouds, shapes in shadows, meaning in randomness. Scientists call this phenomenon pareidolia, our tendency to see familiar shapes where none actually exist. So is that what's happening here? Are we just projecting our imagination onto alien landscapes? Or is Mars telling a deeper geological story we don't fully understand yet? Because here's something important. Mars was not always the frozen desert we see today. Billions of years ago, it had flowing water, rivers, lakes, possibly even oceans. And where there is water, there is chemistry, there is change, there is potential. The question isn't whether Mars looks strange. The question is, how much of Mars' history have we truly uncovered? What forces shaped these formations? Wind, water, volcanic activity, or something we haven't considered yet? Right now, there is no confirmed evidence of ancient cities, no verified ruins, no proven artificial structures. But there are questions, and in science, questions are where discoveries begin. So instead of jumping to conclusions, let's investigate. Let's analyze the angles, the erosion patterns, the surrounding terrain. Because the truth about Mars won't be found in assumptions. It will be found in evidence. And that journey is far from over. Stay with us, because the red planet still has stories buried beneath its surface. And we are only starting to listen. Before we jump to conclusions, we must accept one uncomfortable truth. The human brain is designed to recognize patterns that it searches for meaning, even where none may exist. We see faces in clouds, animals in mountain shadows, familiar shapes on the surface of the moon. Science calls this phenomenon pareidolia, the tendency to see meaningful patterns in random objects. So we must ask ourselves honestly, are Mars rocks simply another illusion created by our own minds? Or is Mars different? NASA's rovers, Curiosity and Perseverance, have sent back thousands of high-resolution images from the Martian surface. And among those images are formations that shocked not only the public, but scientists as well. Rocks with straight edges, sharp, right-angled corners, layered structures that resemble bricks, circular holes that look drilled rather than eroded. Some formations resemble broken walls. Others look like stair steps. Some appear stacked, almost intentionally. The question becomes unavoidable. How does nature create shapes that look designed? According to scientists, Mars once experienced flowing water billions of years ago. It went through intense volcanic activity. Extreme temperature changes fractured its surface again and again. These forces can crack rocks into straight lines. They can create layers, angles, and sharp edges. On Earth, we see similar formations. The Giant's Causeway, basalt columns, Salt crystal structures. They look artificial, yet they are completely natural. Scientists argue that most Martian rock formations can be explained through geology alone. But here is where things become interesting. Some structures do not fully fit these explanations. Their angles are too precise. Their placement doesn't seem random. They stand apart from the surrounding terrain. And perhaps most importantly, NASA often uses careful language. They say the formations are likely geological, but likely does not mean confirmed. That single word leaves room for uncertainty. Are we seeing the full picture, or are some answers still missing? Many scientists agree on one undeniable fact. Mars was once very different. It had liquid water, a thicker atmosphere, conditions that may have supported life. If that is true, then we must ask a difficult question. Is the possibility of ancient Martian life truly zero? This is not about selling alien fantasies. This is not about science fiction. This is about curiosity, because every major discovery in human history began as a question people were afraid to ask. What seems impossible today often becomes tomorrow's accepted truth. So what is the reality? Most Mars rocks are almost certainly the result of natural processes, but some shapes, some patterns, still challenge our understanding. Science does not advance through denial. It advances through curiosity, and Mars remains a planet full of unanswered questions. Now I want to ask you, do you believe these shapes are just coincidence? Or are we closer than ever to uncovering a deeper truth? A red planet, and a story written across billions of years. Welcome to All About Mars Surface. This is Mars. Mars Surface, and this chapter begins with a question that refuses to stay silent. How did a world once shaped by water become the frozen desert we see today? Today's episode explores the changing climate of Mars, a planet that now appears cold, dry, and lifeless, yet still carries unmistakable evidence of a dramatically different past. The surface of Mars is not just rock and dust. It is a record, a timeline carved by atmosphere, water, and time itself. Long ago, Mars was not the hostile world we imagine today. Billions of years in the past, the planet was wrapped in a much thicker atmosphere, dominated by carbon dioxide and enriched with nitrogen and water vapor. This atmospheric shield trapped heat, keeping surface temperatures warm enough for liquid water to exist freely. Water did not hide underground. It moved openly. Rivers cut through vast plains. Lakes filled deep impact craters. Rain may have fallen during warmer eras. These were not brief moments. The Martian surface tells us this environment lasted long enough to reshape the planet. Even now, Mars preserves the fingerprints of those ancient climates. Valley networks stretch across the terrain. Dry riverbeds wind through empty basins. Delta structures fan out where water once slowed and spread. These formations are not accidental. Their shapes mirror water-formed landscapes on Earth. They show erosion, sediment layering, and sustained flow over long periods. Such features could only exist under a climate capable of supporting stable liquid water for extended time spans. But Mars did not remain this way. A major turning point came with the loss of its global magnetic field. Early Mars likely possessed a molten core that generated a magnetic shield similar to Earth's. This invisible barrier once protected the atmosphere from the relentless force of the solar wind. When the magnetic field weakened and eventually vanished, Mars was left exposed. The sun began to strip the planet bare. Charged particles slowly tore away the upper layers of the atmosphere. As the atmosphere thinned, surface pressure collapsed. Liquid water could no longer survive. It froze, evaporated, or escaped into space. Rivers slowed to a stop. Lakes vanished. What remained either sank underground or locked itself into ice beneath the soil and at the poles. This transformation was not sudden. Mars experienced long cycles of change, periods of warming followed by deep cooling. Massive volcanic eruptions once released gases that briefly thickened the atmosphere and raised temperatures. When volcanic activity declined, the planet cooled again. These repeating cycles built layered deposits of ice, dust, and rock that still exist today. Nowhere is this history clearer than at the Martian poles. The polar ice caps are stacked in layers like the rings of a tree. Water ice and frozen carbon dioxide record shifts in temperature, pressure, and dust levels across millions of years. By reading these layers, scientists reconstruct Mars's climate history with remarkable precision. Mars's orbit also plays a critical role. Its axis is tilted much like Earth's, creating seasons, but its elliptical orbit makes those seasons uneven. Over long time scales, the tilt itself changes far more dramatically than Earth's. These variations force ice to migrate across the planet. At times, ice moved toward the equator. At other times, it retreated back to the poles. These hidden regions are now among the most important targets for future exploration. For future human missions, Mars's climate is more than science. It is survival. Dust storms, radiation, temperature extremes, and long-term atmospheric behavior will determine where humans can land, live, and extract resources like water ice. Mars delivers a powerful lesson. It shows how the loss of a magnetic field and atmosphere can transform an entire world. It reminds us that climate is not permanent. It is shaped by deep planetary forces over time. The red planet stands as a record of water lost, air stripped away, and temperatures driven to extremes. But Mars is not only a warning. It is also a guide. By studying its climate history, scientists gain insight into Earth's past and possible future. The same physical laws govern both worlds, linking their stories across space. Mars continues to evolve. Its ice still moves. Its atmosphere still flows. Every season adds another line to its long, silent record. All About Mars' surface will continue following these changes, exploring how time reshapes planets and how Mars preserves its history in dust, ice, and stone. Share your thoughts in the comments. Like this video. Subscribe to All About Mars Space.